My name is Lahiruddin Silva and my index number is 170109H. Our project is Emergency Alerts and Incident Reporting System. So basically I am dealing with the backend part and the database and the location clustering part. So before I move into the code, I will give a brief introduction about our system architecture. So for the project, we are following the microservices architecture pattern, and you can see we have implemented several services here, and all these services have to be accessed to the API gateway. And when we are talking about the project, we have implemented several services, and each of these services has a separate folder. And inside the folder, we have modeled the service into three layers. Like in the MVC pattern, we have a separate model for each of the services, and we have a controller, and we have a router. So all these services are running inside Docker containers. So here in the Docker Compose file, you can see we have implemented 6 containers, out of which 4 containers are used for services and 2 containers are running databases. So for the project, we are using two type of databases. We are using Postgres as the relational database management system. So here we store all the data related to government institutes and user data. And the second type of database is called the RethinkDB. This is a real-time database, so that means when we do a change to the database, the change will be automatically pushed to the application. So this is very important for us to implement the real-time messaging services, the real-time messaging service between the government organizations. So to start our application, we have to run one single command. We have to run the containers. So you can see each of these containers are starting, and the application is now running. So here in the Docker containers, you can see we have 6 containers running. And when we talk about our databases, so far we have like 16 tables, and we have like 5 to 6 procedures. So most of the things are done through stored procedures, and we have implemented transactions, so we ensure the data consistency among the databases and tables. And also in our application, we have to do some geospatial searches. That means we have to search uh, the GPS coordinate and find the nearest hospital or find the nearest police station. For that, we are using an extension called PostGIS, and it is a separate extension built for the Postgres database. So by using PostGIS, we can write some algorithms that help us to determine the closest hospital, closest fire station, and things like that. You can see here we have several geospatial algorithms. And apart from that, this is the location clustering. So I have created a map, and I have covered the whole Sri Lanka using these hexagons, and each of these hexagon has a separate hash code. So when we take a user location, we only need to search through this hash code to determine in which province he is in. So like 80% of the backend part and the database is now completed. Most of the core features have implemented, and we have like 20% of 15% remaining to do.
For the project, we have to develop an NLP model that classify the user messages into different categories so that they can be directed to relevant authorities. First, I thought of classify messages as relevant, irrelevant, and cannot be decided, and later identify the relevant categories. In the first 2 attempts, I have tried several classifiers on Kaggle social media dataset and Figure 8 disaster dataset with preprocessing techniques such as removal of punctuation, snowball stemming, while comparing TF-IDF and count vectorization. However, the TF-IDF vectorization done in the second dataset gave me a better result than the first attempt. Next, I combine the two data sets and follow the same preprocessing techniques, but results were poorer than the second attempt. As the third attempt, latent directional analysis was done for topic modeling on Kaggle dataset, but perplexity and coherence scores was poor. For the fifth attempt, Figure 8 dataset was used. It was originally classified into 36 categories, and for the sake of the project, I have reduced it to 14 categories. I have approached the problem as a multi-label classification problem. For preprocessing, I removed all URLs, numbers, and punctuations, and was subjected to stemming and lemmatization. Model selected was multi-output classifier with random forest as the estimator. For each class, pair accuracies was obtained. I have also developed a Flask web API which uses the model for classification purposes. This is the Python project for the Flask API that I have developed. Let's see a demonstration for the predictions. Currently, I'm working on a recurrent neural network which performs better than the previous model. Let's see the prediction the two models done on a same message. I need an ambulance.
This is the live tweet analyzer of our incident reporting system. The system can analyze the tweets posted in Twitter and present the data to authority to make decisions. The user can filter the tweets using any tag or keyword or location, time duration, and number of tweets. For an example, these are some recent tweets extracted from Twitter which are relevant to COVID-19 virus in Colombo. So by analyzing the sentiments of people, authority can get an idea about how people think about the situation and what are the areas that should focus, and they can take necessary actions. The Twitter sentiment analyzer is built using a natural language processing model with scikit-learn. As the first step, finalize the dataset to train the model and refine the dataset to contain tweets tagged with negative and positive labels. Then, Natural Language Toolkit is used to create the corpus with preprocessed data. For feature extraction and creating the bag of words model, Count Vectorizer and TF-IDF Vectorizer from scikit-learn is used. For classification, we have created 3 classifiers: naive Bayes, logistic regression, and random forest classifier. In order to optimize the model, ensemble method is used on those 3 classifiers, and the model gives predictions for the test set with 70% of accuracy. For the application, Twitter Scraper library has used to stream live tweets and feed the model.